Imagine every computer process as a journey made up of bursts, quick sprints of activity, followed by moments of waiting. This simple pattern shapes how computers juggle multiple tasks, making it essential for understanding process scheduling. Let's begin with the core sequence, the CPU I/O burst cycle. Each process alternates between two main states. During a CPU burst, the process is actively executing instructions, making progress on its computational work. These periods can be very brief, or sometimes surprisingly long, but most processes experience many short CPU bursts with just a few longer runs mixed in. When a process needs to fetch data, write files, or interact with devices, it enters an I/O burst. Now it waits on input or output operations while its instructions pause. During this time, the CPU isn't tied up. Other processes can step in and use the processor, allowing the system to stay efficient and responsive. If you visualize this, a process might flow like this: CPU burst, then I/O burst, then another CPU burst, and so on, until finally reaching its last tasks. Not all processes look alike. Some spend most of their time in I/O bursts. These are called I/O-bound processes. Think of web browsers, or programs that fetch and display data frequently. They have many short CPU bursts interrupted by frequent and sometimes lengthy I/O waits. Fast, responsive performance is key here, because users notice delays. Others are CPU-bound, focusing on heavy computations with minimal I/O. Imagine scientific simulations or complex data analysis. These processes tackle longer CPU bursts, rarely pausing for I/O. Their main goal? Maximizing throughput and completing as much computation as possible. Understanding the CPU I/O burst cycle reveals the hidden choreography of process scheduling. It explains how operating systems keep systems both efficient and responsive, matching the unique needs of each process. With this foundation, you're ready to explore how operating systems optimize the dance between work and waiting, balancing every process for peak performance.